Alright, hello everybody. I am Matt Johnson. I'm going to be talking about bipolar disorder and epilepsy, their genetic origins, and their link to one another. So, I'm sure all of you have probably heard of each of these disorders. Bipolar is, to put it simply, the basics are a alternating mood between a manic high state and a melancholic low. And epilepsy, conversely, is characterized by episodic periods of distress, which indicate an oncoming seizure, basically. So I'm sure most of you probably either know about these already, have met somebody, have family members, and so on that deal with either of these. So, most of you should be pretty familiar, but I am going to go over each of them in a more in-depth way. To start with, we're going to talk about bipolar and its physical and emotional manifestations. Now, as I said, it has two emotional states with varying symptoms. Obviously, there are, sometimes a mixture of both, or a more normal, as you would call it, sort of state. But both of the phases are pretty well fleshed out in terms of their different facets or characterizations. So, the manic phase, the high phase that I was talking about, is characterized by elevated attitudes, high levels of activity, delusions of grandeur and increased self-confidence, decreased need for sleep, heightened sociability, anxiety and racing thoughts. You become easily distracted, and all of these lead to a sort of state of poor decision making. I myself suffer from bipolar, so I can speak of these firsthand, but I am medicated, of course, which I will delve further into. Now, there's also the depressive state, which basically it is the neurotypical definition of depression. It's a very low mood. You'll feel empty, tearful, or sad. There's a loss of interest and pleasure, weight loss, insomnia, or sleeping too much. You could be restless, or you could be very sluggish. You could be suffering from fatigue. You could have feelings of worthlessness and guilt, decreased concentration, and at the worst of it, a sort of suicidal ideation or tendencies. Now, there are two basic types of bipolar. Obviously, not every single case of any mental disorder is the same, but bipolar is characterized by bipolar 1 and bipolar 2. Bipolar 1 is basically there is a very rapid cycling between these two mood states. So it can be days, hours even, but which you will cycle between the two. And then bipolar 2, you have prolonged periods of either one, basically. So you could have weeks, months, even a year dealing with these. So, to move on to the phenotypic manifestation of epilepsy, as it says, it has similarities in that it occurs in an episodic nature. Both of them appear to have a marked sort of randomness to them. But basically with epilepsy, there are episodes that have certain moods and feelings to them which indicate an oncoming seizure. So these will be marked states of confusion, staring off into space, jerking movements in your extremities, so you'll kind of twitch. You can black out or pass out. You could experience severe anxiety or fear, and then you could also have a sort of stiffened, rigid joints and muscles, which all will lead to a seizure which, if you do not know, basically you lose all control of bodily function and sort of shake, and you'll possibly end up on the ground. There are many ways you are supposed to care for people undergoing a seizure, but that is neither here nor there. Basically, it's just an unfortunate circumstance. Now, the research on both of them. Bipolar is not very well understood. It has kind of stagnated research-wise, but there are definite candidates for genes related to its manifestation. One of which is NRG1, which is the one we will be focusing on because bipolar and epilepsy have both been linked to NRG1. Now, earlier in the slide it said comorbidity. Basically, that is the tendency for two disorders to occur simultaneously in a higher frequency than normal. So basically, a lot of people who suffer from bipolar can be epileptic, and vice, you understand. Now, NRG1 specifically, because there are different subclasses of the gene NRG. Basically, NRG is a class of gene that deals with the growth and development of glial and neuronal cells. Now, it undergoes alternative splicing, which we've learned about recently in class, to create different isoforms of it. This has a lot of different varieties. I think it's up to 7. Now, the main one is NRG1, 2, and 3. NRG1 is the one that is linked to both. The main function of the cells that are encoded by this gene deal with cell-to-cell communication. They're called signaling cascades. And what it would appear is that both disorders undergo a sort of error in this signaling cascade, making it a sort of randomized sort of mood, or, obviously the physical aspects of epilepsy. And both of these, ultimately, what's important that led me to this topic is that they both use the medicine lamotrigine, or commercially called Lamictal. This is a chemical makeup of lamotrigine, which doesn't necessarily have anything to do with it. But lamotrigine is classed as an anticonvulsant. It is shown to have a profound effect on both of these disorders, because what happened is that there was a very marked difference in the people that suffered from both, in which both of their symptoms were lessened. So, ultimately, all in all, this medication is what led me to this, because I take medication, specifically lamotrigine. Basically, I sort of had this general idea because of knowing that both disorders are treated with this same medicine. And the idea that lamotrigine sort of, it stabilizes the firing of neurons on that signaling cascade, kind of makes it seem as if both of them are undergoing a random firing of neurons, leading to both of their symptoms. Now, like I said, there's very little concrete evidence, but this is what I believe links the two together and explains their comorbidity and, the similarities between them. And thank you.